Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel if you haven't subscribed it yet. Now let's solve this particular problem related to the friction topic, right? So in this problem it is said that the force P is applied to the 50 kg block when it is at rest. It is said that determine the magnitude and direction of the friction force exerted by the surface on the block if P equals to 0. We have three different P values, right? And in the part D of this problem, it is said that what value of P is required to initiate motion up incline, right? And further it is stated that the static and kinetic coefficient of friction between the block and incline are 0.25 and mu k equals to 0.20 respectively. So this is a very interesting problem. In this particular problem we will learn all the cases that we will deal in the friction problems, right? So let's define our coordinate system, right? So let's say that this is my positive x-axis, right? In this direction, let's say this is my positive x-axis, and let's say that in this direction this is my positive y-axis perpendicular to this inclined plane, right? So this is y-axis, right? And this incline is making 15 degrees, right? So now as we can see that this surface will apply the normal force on this 50 kg block, right? So let me draw that, let me represent that normal force. So that normal force will be acting like this, that is in the positive y direction. Let me write that this is normal force, right? And then the weight of this block will be acting downwards, right? So let me draw that weight as well. So this is the weight which will be acting vertically downward, right? So we can show that weight here, right? And similarly the friction force will, let's assume that the friction force is acting vertical along the plane in the downward direction, right? So let's say that this is our friction force that is acting between the two surfaces, right? This is the friction force, right? This is the weight, and weight is 50 times 9.81, so this is 490.5 newtons, right? And we can resolve this P force into its components along the x and y axes. So let me resolve this P force into its components, right? So it will have one component which will be acting in this direction. So this component is we can say that this is P cos of 20 degrees. And similarly, we will have one component along the y-axis which will be acting like this, right? So this is parallel to the y-axis, and this is the sine component. So we will write that this is P sine of 20 degrees, right? Similarly, we have to resolve this W force, right? So this W force, this weight makes 15 degrees with the y-axis, since the inclined plane is making 15 degrees with the horizontal, right? So how? So let's say that this is that inclined plane which is making 15 degrees, right? And this weight is acting vertically downward. So this is that weight, right? And this y-axis is perpendicular with this inclined plane, right? So this is that y-axis, this is that y-axis, right? So y-axis is perpendicular with this line, and this weight is perpendicular with this horizontal, right? So if the angle between these two is 15 degrees, so the angle between the weight and the y-axis is also 15 degrees, right? So here we have 15 degree angle, right? So now we can resolve this weight into its components, right? So it will have two components. It will have one component which will be acting vertically downward. This will be the cos component. So this will be the cos component of this weight, right? So we can write that this is W cos of 15 degrees, right? And similarly, we will have one other component of this weight which will be parallel to the x-axis like this. So this is the sine component, right? So now let me assume that the system is in equilibrium, right? So let's say that we are assuming that the system is in equilibrium. So for equilibrium, we will apply the summation of forces along x equals to 0. So if we apply the summation of forces along x, so then we can see that we have this P cos of 20 force acting in the positive x direction. So I will write P cos of 20 degrees, And similarly this F force is acting in the negative x direction, so I will write minus F. Similarly this component, this sine component, right, this is W x component, right, so this is acting in the negative x direction, right, so I will write minus, and Wx is the sine component, so we can write that this is 490.5 sine of 15 degrees, right, and this will be equal to 0. So now we can simplify this. We can write the friction force in terms of these two, right, so we can write that this F, if we bring this F to the other side, right, so this will be equal to P cos of 20, and cos of 20 is 0.94, right, so I can write this is 0.94 P this minus, and this 490.5 sine of 15 is 126.95, right, so this is minus 126.95. so let's say that this is our equation 1. Now if I apply the summation of forces along y equals to 0, so as we can see that this normal force is acting in the positive y direction, so I will write n. Then this cos component of this weight is acting in the negative y direction, so I will write minus this component, right, so this is 490.5 cos of 15 degrees, right, and similarly this component is acting in the positive y direction, so I will write plus P sine of 20 degrees, and this is equal to 0, right, so we can write this. So if we bring these two terms to the other side, so they will become their sign will become opposite, right, so n will be equal to minus, and this will become plus, and this will become minus, right. So now we can simplify this. So this n will be equal to, the sine of 20 is minus 0.34, right, so let me write that this is minus 0.3, or let me write first this is equal to 473.79, and this is minus 0.34 P. So this is our equation 2, right. So now these are the generalized equation in terms of P, right. So now we have 4 cases, right. So in case number 1, when it is said that P is equal to 0, what is the value of the friction, right. So now when P is equal to 0, so if we put P equals to 0 in this equation 1, so we will get that friction force is this term will become 0, right, so we will be left with this, right, so friction is equal to minus 126.95 Newton, right. So minus sign means that when P equals to 0, the friction force is acting in the upward direction, like this, in the positive x direction, right. So this means that this block is tend to moving in the downward direction, right, so the friction force will be acting in the opposite direction. So this minus sign means that the friction F is acting up the plane, right, since we have assumed that the friction force is acting down the plane, but here we have minus sign, so minus sign means that the friction force is acting up the plane, right. And now this is the friction force, right. So now if I substitute P equals to 0 in equation 2, so then we will get that normal force. So normal force will be equal to, so if we put P equals to 0 in this equation, so we will be left with 473.79, so this is 473.79 newtons, right. And if we find F max, right, let me find F max. So F max, the maximum friction force that this surface can offer will be equal to mu s n, and mu s is given, right, here mu s is 0.25, so I will write that this is 0.25 into 473.79, so this gives us 118.45 newtons, right, so 118.45 newtons. So if we compares the magnitude of F and F max, right, so the magnitude of F is 126.95, right, So that 126.95 is greater than this F max, right? So this means that this friction force value is not accurate, that we got from assuming that the system is in equilibrium, but the system is not in equilibrium, right? Since the surface can offer a maximum friction of 118.45 newtons, right? But the friction value from these equilibrium condition is 126.95, right? So this means that the friction value is more than the offered value, the maximum friction that can be offered, right? So this means that the system is not in static equilibrium, right? So if the system is not in static equilibrium, so this means that this block is moving downwards, right? Since the friction force is acting in this direction, right? So if the friction force is acting in this direction, so this means that the block is moving downward when P force is equal to 0, right? So then we can find that friction value, the accurate friction value from this equation. We can say that this will be equal to mu Kn. So now friction value, and now mu K is given, which is 0.20. So I will write 0.2 into N. So N is this thing, right? So this is 473.79. So 0.2 into 473.79. So this gives us 94.758. So we can say that this is approximately 94.8 newtons, right? So this is the accurate value of the friction for case E when P equals to 0. Now in case B, it is said that P equals to 200 Newton, right? So P equals to 200 Newton, and then we have to find the friction force, right? So again we will use both of these equations, right? So now if I put P equals to 200 in this equation 1, right? So I will put it directly in calculator, right? So I can write this equation as minus 126.95 plus 0.94 into 200. P is 200, right? So this gives us the friction force as 61.05, right? So I will write that it is 61.0, let's say, Newton. And if I put P equals to 200 in equation 2, so that is 473.79 minus 0.34 into 200. So this gives us N equals to 405.79, right? So N is approximately 405.8, let's say, right? So now if we find F max for this condition, so F max is equal to, again, mu Sn. So mu S is 0.25 and N is this thing, right? So this is 405.8. So we can multiply this answer with 0.25, right? So this will give us 101. So F max is 101 Newton approximately. So now we can see that this friction force is less than F max, right? So this means that if this is the case, the surface can offer a maximum friction force of 101 newtons, right? So the friction value from these two equations, from the assumption that the system is in equilibrium, we get as 61.0 Newton. So if this is the case, if F is less than F max, so this is the accurate value of that friction for this case B, right? So this is the right answer for case B. If P equals to 200 Newton, then the friction the surface is offering is 61.0 Newton. And again, the sign of this friction force is positive, right? And in these two equations, we are assuming that the friction force is acting downward, right? So for case B, the friction value is, we can write that the friction value is 61.0 Newton, and the direction is up the plane, right? Sorry, it is down the plane, right? Since we have assumed that it is down the plane, right? So I will write that the direction is down the plane, right? And in case A, the direction is, the friction magnitude is 94.8 newtons, and it is up the plane, since the sign is negative here, right? So we can say that this is up the plane, or we can say that it is up the inclined plane, right? Now for case C, we can write that for case C, P value is now 250 newtons. P value is now 250 newtons. So again, if I substitute P values in those two equations, and we are required to find the friction magnitude and direction, right? So now if P value is 250, so we have to put P equals to 250 in this equation 1, right? So we have this equation that minus 126.95 plus 0.94 into 200. So now P force is 250. So I will put 250 value in that equation 1. So we get F equals to 108.05, right? So this is equal to 108.05 newtons. And again, if I put P equals to 250 in this equation 2, this is 473.79 minus 0.34 into 250. So this gives me N value as 388.79. We can find F max again. So F max is again 0.25 into this N. So this is 0.25 into answer. So this gives us 97.19, right? So 97.19 newtons, right? So again, if we compare F with F max, so F, whose magnitude is 108.05 newton, is greater than F max. So if P equals to 250 newton, the surface can offer a maximum friction of 97.19 newton, right? And from the static equilibrium conditions, we get F equals to 108.05. So this means that this is not accurate for this condition. This friction value is not accurate, right? So then what we need to do, this means that if F is greater than F max, so the assumption is not valid, right? This assumption is not valid. So if the assumption is not valid, this means that this 50 kg crate is moving, right? And the friction value is positive, so this means that the assumed direction is accurate, right? So this means that again for this case C, and the friction direction is down the incline, right? So this means that if this is down the incline, so this means that the crate is moving up, right? So if the crate is moving up, the friction force will be acting down the plane, right? So now we can find that magnitude since the crate is moving, so we can find it by using the kinetic coefficient friction, right? Coefficient of kinetic friction. So this will be mu k n. So now mu k is 0.20 into n. So for this case, n is 388.79. So this is 0.2 into 388.79. So this is 77.758. So let me write that this is approximately 77.7 newtons, right? So now this is the accurate value of friction for this part C, and the direction, we get the direction from this, right? Since the sign is positive, assumed direction is down the plane, so this means that this is down the plane. Now in case D, it is said that what value of P, now we have to find the P value. What value of P is required to initiate motion up the incline? So this is very important. So if the motion is just impending, so at that particular instant, the friction value will be max. That will be the maximum value. And the maximum value is how much? So it is mu Sn. Right, so mu s is known. So mu s is 0.25, so 0.25 n. Right, so for case D, we will use the F value as 0.25 n. So now in case D, we will use F value as 0.25. So let me write that for D, F is equal to F max, and F max is equal to 0.25 n, and we are required to find P value, which will give us that maximum friction, and for that P value, this crate will start motion, right? So now if I put F equals to 0.25 in this equation 1, so we will have 0.25 n equals to 0.94 P minus 126.95. So now this is our equation 1 for this case D. And similarly, equation 2 is n 473.79 minus 0.34p. So now if I multiply this whole equation 2 with 0.25, right? So let me multiply this whole equation with 0.25. So this will be, let me write it here. So this will be 0.25n. This will be 0.25 into 473.79. And this is, let me write this p term on this side, right? So this will be 0.25 into minus 0.34p, and this will be plus 0.25 into 473.79. And let me write equation here, equation 1 here, right? So I will write this equation 1 here. So this is 0.25 and 0.94p and minus 126.95. So now if I subtract equation 1 from 2, this is our new equation 1. This is that equation 1, this is equation 2. So if I subtract equation 1 from 2, so this sign will change, this sign will also change, and this will also change. So this will become positive. So this will be cancelled out. This is 0. This will be, we will add up both these coefficients, right? So this will be 0.25 into minus 0.34 minus 0.94. So this is minus 1.025p, minus 1.025p, and similarly we will add up both of these as well. 0.25 into 473.79 plus 126.95. So this is 245.40, right? So plus 245.40. So now we have this equation. So only p is unknown. We have eliminated that n from these two equations, right? So now p will be equal to minus 245.40 divided by minus 1.025. So we can write that answer divided by 1.0025. So this gives us p value as 239.41. So we can say that it is approximately 239 newtons. So now if this p force is equal to 239 newtons, right? So at that particular instant, this block will start moving up the plane, and at that particular instant the friction force will be maximum, and that maximum value will be 0.25 n, and we can find that n value from this equation since we know p. So if you want to find that f max, we can find it, right? So let me find it. It's not the part of the solution, but we need, if you want to find that n value, we can find it using this equation 2, since now we know p value for f max, right? So then that n value will be 473.79 minus 0.34 into p, which is 239. So then that n value is 392.53 newtons, and then f max is 0.25 times this n value. So I will multiply this answer with 0.25. So this is 98.13. So f max is 98.13 newtons. So now if p value is 239, so we will have maximum frictions of 98.13 newtons for this part D. So I hope you people would have understood all these 4 parts of this particular problem. This is very important problem. If you understand it, so you people will apply this concept to all the friction related problems. So kindly like my videos if they help in your learning, and kindly write in the comments if you have any questions related to this particular problem.